Okay, so last time we were working, we were trying to find all the trig functions for a 45, 45, 90 triangle. And so when you look, we had defined, so to kind of try to get you back in the mode, we had defined what the 6 trig functions are. So we said we could figure out the first ones by some old horse came a hopping through our alley, and you're going to need to memorize those. And then we said these are the reciprocal functions. Okay, so if you can remember that the C goes with the S, okay, cosecant goes with sine, secant goes with cosine, S going with the C, and then tangent, cotangent is easy to remember, that these are just the reciprocal. So where this is opposite over hypotenuse, just flip it. Adjacent over hypotenuse, just flip it. Opposite over adjacent, just flip it. Okay, so we had drawn a 45, 45, 90 triangle, and we said that the sides are 1, 1, and square root of 2. And Sophie, who's not here, said, well, what is it if they're not 1, 1, and square root of 2? Looking in her spot. We said it would be x, x, and x squared root of 2. So these are just ratios, but to me it's easiest just to remember 1, 1, and square root of 2. And once you draw that, you can find all of the trig functions just by looking at your angle. So we had done sine of 45 was opposite over hypotenuse, so 1 over the square root of 2. And we rationalized the denominator. So we multiplied by the square root of 2 over square root of 2, and so we got square root of 2 over 2. Okay, it was the same thing for cosine because adjacent over hypotenuse was 1 over square root of 2, so we didn't bother working it out because it's the same thing. And then tangent was opposite over adjacent. Okay, and then sad for me, the bell was ringing before I got to the end of this one. But these are the reciprocal functions. So for cosecant, all you have to do is flip what you got for sine. And so if we flip it before we rationalize it, it saves us some trouble. So if you flip 1 over square root of 2, you get square root of 2. And flip 1 over square root of 2, you get square root of 2 again. Okay, and then finally the tangent. If you flip 1 over 1, what are you going to get? Yes, still 1. Okay, so remember the quiz that we're going to have. First thing it's going to say is define all 6 trig functions. You will write down this and this. Okay. Then I will ask you to write down the 6 trig functions for 45 degrees. The easiest way is to draw the triangle and then just figure all this out. But all I'm looking for is the answer. So if you want to memorize just the answers, you're going to get the same credit. Okay, I just think it's easier to learn the triangle than it is to have to memorize it. Okay, and then what I want to do is the 30, 60, 90, and the 45. I'm sorry, we already did just the 30 and the 60 is what I meant to say. So we need a 30, 60, 90 triangle. You can write the 30 and the 60 wherever you want, but the sides opposite it, it matters where you put them. Does anybody remember anything about the ratios of 30, 60, 90? Any of the numbers that you use? 1 is one of the numbers. There is a number 2. Square root of 3. Good. Those are the 3 numbers that we want to arrange, but we have to arrange them correctly. Does anybody know how big the square root of 3 is? Use a calculator if you want. 1.7, yeah. So really, if we put these in order from smallest to largest, it wouldn't go in that order. It would go 1, square root of 3, 2. That's from smallest to largest. And the smallest side is across from the smallest angle. Okay, so across from the 30, you want to put the 1 because that's the smallest angle. Across from the 60, you want to put the square root of 3 because that's 1.7. That's the next biggest. And then 90 is the biggest angle, and also the hypotenuse is always the biggest, so that's where you want to put the 2. If you get that right, you'll get all the trig functions right for 30 degrees and all the trig functions right for 60 degrees without having to memorize anything. Okay, you can just use your triangle. If you switch these and do them backwards, you're going to get most every single problem wrong. Okay, so you really need to memorize that. So what we're going to do is first do all the trig functions for 30, and then we're going to do all the trig functions for 60. For your quiz, I will either ask you 30 or 60, not both. I'll just pick one, okay, because it shouldn't matter which one I do. They're both just as easy. Okay, so write sine, cosine, and tangent, and then over here, what's the reciprocal of sine? Cosecant. And then the reciprocal of cosine? and the reciprocal of tangent. Perfect. Okay, and then I'm just going to do some old horse came hopping through our alley. Okay. Now when I do this, I need to compare everything to 30 degrees. So right now, this is the angle I'm talking about. Oh, it's smeared. That looks disgusting. Let me go for yellow for the next one. So label everything in relation to the 30. So first thing you label is the hypotenuse, okay, because that doesn't change no matter which angle you're talking about. For 30 degrees, what would 1 be? Opposite or adjacent? Opposite. So right here, this guy is right across from it, and what about the square root of 3? Adjacent. So once you label that, you can just put them all the way through, okay? If you have a square root in the denominator, then you're going to need to rationalize it. So I'm going to give you a minute and see if you can fill these in, and then I'm going to let some people come up and fill them in.
Hey guys, how's it going? Hey Yiggers. This is me doing math. So 3 equals 1 over 2 equals what? Oh, let me do this. I can do this. So if I can label the sides for sine 30. So this is the hypotenuse. Oh, you already did that. That's why. So if I over h 1 over 2. That's how I got that. And for this one, be a over h, so it would be square root of 3 over 2. Which rounds out to be 0.866.
Okay. So for tan 30, it's, how do you do this? Opposite over adjacent. So that's the square root of 3, or no, 1 over the square root of 3, sorry. And since you can't have a square root in the denominator, you have to multiply it. Square root of 3 over square root of 3. And that comes out to square root of 3 over 3. And then for cosecant, it's the opposite of sine, so it's hypotenuse over opposite. So that's 2 over 1, and that equals 2.
Hello, it's me again. I'm gonna do the last two because no one else wanted to. This is Ellie. I have to do this flip. I'm eating a Starburst. I have to do. Let's flip these. It's gonna look like this. I just flip that. Do that again. This would be 2. The square root of 3. You say I don't have to simplify it, right? Oh, now I do. I have to rationalize the denominator? Oh my goodness. Okay. And 2. And the bottom line, that comes out to be what? Just 3? Right? Okay. Good, that's that. And then all I have to do is switch the last one again. Huh? Okay. And it just equals square root of 3.
Okay, so now we're going to do the same thing, find all 6 trig functions for 60 degrees. So the only difference is I need to relabel my sides. Okay, so you can use the same triangle, but now we're talking about 60 degrees. So that's up here. Okay, the sides values are all the same. Okay, but what's adjacent and what's opposite switches? So compared to 60, 1 is right by it. Okay, so this guy would be adjacent. And compared to 60, square root of 3 is opposite that. And then the hypotenuse is still 2. Okay, so all we're going to do is the same thing for 60. You just have to use the new sides. So we have sine, cosine, tangent. That's our some old horse came a hopping through our alley. And then you're going to do the reciprocals, cosecant, secant, and cotangent. And when you're learning these for the test, you do not have to do any decimals, so I'm just going to cross those out. You're going to give me exact values, which are the fractions. Okay, so like up here, these are the ones we're using. That's what I'm looking for your answers. Okay, and on your quiz, I will either ask you to find all the 6 trig functions for 30 or all the 6 trig functions for 60. I'll just dealer's choice on that day. Okay, so the 3 questions are write down the definitions of all 6 trig functions, find the 6 trig functions for a 45-degree angle, find the 6 trig functions for, and I will either say 30 or 60, and that's the quiz. Okay, so I'm going to pause and then have some volunteers come up when they're ready for all of these values.
Okay, so sine is opposite over hypotenuse, which for 60 degrees is going to be square roots of 3 over 2. And then cosine is adjacent over hypotenuse, which is going to be 1 over 2. So then for the tangent, it would just be square root of 3 over 1. And then for the cosecant, it would be 2 over square root of 3, but you have to rationalize it. So you would multiply it by square root of 3 over the square root of 3, and that would come out to be 2 square root of 3 over 3.
Do I need to say my name? Alright, so now we've got secant of 60, and that's going to be the opposite of cosine, so it's going to be hypotenuse over adjacent, which is going to be 2 over 1, which is just equal 2. And then the cotangent is going to be the opposite of tangent, and that's going to be adjacent over hypotenuse. So that's going to be 1 over the square root of 3, and you multiply both sides by the square root of 3. That's going to equal the square root of 3 over 3.
Okay, so that's your quiz that you're going to have. Be prepared. First question, find all 6 trig functions. There's your answers in red. How often does the teacher give you the answer key right before a test? Very often. Okay, find the 6 trig functions for 45. There's your answers. Okay, you're going to use it. Has to be rationalized, no options. Okay, so you're going to use the rationalized denominator forms. Okay, find the 6 trig functions. I will either say for 30 or for 60, whichever one I do. Give the answers in the rationalized form. Okay, so you don't have to show me the triangle, but to me that's the easiest way. Then you don't have to memorize very much. Okay. All right, so now what we're going to do is just see how we can use these 6 trig functions to solve for some unknown values. Okay. So here I have a triangle, and it only gives me 2 of the sides. And if I want to find all 6 trig functions, which is what this asks me to do, then I'm going to need to know all 3 sides. Okay, so the first thing you want to do is solve for whichever side you don't have. So any thoughts on how I could solve for the hypotenuse? Oh, she's so smart. Okay. So Julia told me I could just use this, and that's definitely true. Okay, but I'm going to just write it like you would think of normally. She can go straight there. Okay, but this will work if you just use the Pythagorean theorem to solve for whichever side it is. She's got it already isolated for the hypotenuse for me, and A and B are either side, and C has to be the hypotenuse. Okay, so this would be my C. It doesn't matter between A and B as long as they're the other 2 sides. So I'm going to do 15 squared plus 8 squared equals C squared. And then I'm going to say, boy, I hope Amber's got her calculator ready. 15 squared seems like it's going to be a really big number. What's 15 squared? Oh, it sure is. Okay, I think I can handle the 64. All right, so all together, we've got 289. So the square root of 289. All right. Believe it or not, that's one of the special triangles that they say you can memorize for the ACT to try to save yourself time. It's not one of the ones that's in my head, so I would probably just take a second and solve. The what? Yeah, yeah, exactly. It's not one of the ones I remember. I mean, 3, 4, 5 I remember, but so once you know that, we're really just going to be doing the same thing we did before. The only thing is it's going to be easier because I don't have to rationalize anything. There are no square roots in this one. They're all perfect. So I kind of am regretting taking up that much room. Oh well. Sine, cosine, tangent. Some old horse came a hopping through our alley. Okay, and then reciprocals, cosecant, secant, cotangent. And I'm going to wait and have some of my stars of my show come fill these in for me. The first thing you will need to do, though, is label whoever's first. Here's where they put theta. They could have put it either spot. Could have been up here. In fact, would you rather it be up there? No, they'd rather it be down here. Okay, so label hypotenuse, adjacent, opposite in reference to this angle, and then fill in a couple of our trig functions.
What's up, guys? It's Dylan. We're going to do some math. Alright, so I'm going to be doing sine. And for sine, we have the opposite over the hypotenuse, so that's 8/17. And for cosine, we have adjacent over hypotenuse, so that's 15/17. And shout out my man Carter, but I really doubt you're watching this.
Hey guys, it's Emma. So now we're doing tan, which is opposite 8 over adjacent 15. And then cosecant, which is hypotenuse over opposite. So hypotenuse is 17, and opposite is 8. Okay, now Ellie's gonna go again.
Hello, it's me again. This is Ellie. I probably shouldn't cover that up with my paper. So all I have to do is switch this. So it's gonna be h over a, like ha, and then the next one is gonna be a over o. So all I have to do is switch. What? Oh, because I made a sound. Oh, okay. So all I have to do is switch the numbers from the last one. So this is gonna be 17, 15, and then I'll have to switch that again. This is going to be 15 over 8.
Okay, so if we take a look at our next one, we're doing the same thing, except that we have to solve instead of for the hypotenuse for one of the other sides. I do think I want to change my theta though, so let's forget this theta. Let's make theta up here, just so we realize that adjacent and opposite are relative to wherever they give you the angle for. So trying to solve for this, I'm going to say, let's do it over here, 2 squared plus b squared. 2 pink starbursts. This is big news. Both got 2 pink. All right, pressing news. The ladies both got 2 pink starbursts. All right. 2 squared plus b squared equals 6 squared. So we have 4 plus b squared equals 36. Subtract 4. B squared equals 32. And then we're sad because it's not a perfect square. Take the square root. So b is the square root of 32. And let's break down 32. Can you think of 2 numbers? I want you to think really carefully. That multiply to give you 32. And I want you to think of the biggest perfect square that'll go into 32. 16 is good. Thank you, Dylan. So 16 times 2. So this would be square root of 16 is 4. And square root of 2, we can't do anything perfect with that, so we'll leave it like that. So this would be 4 square roots of 2. Okay. And what I'm going to do is just make sure and label my sides relative to that angle. So across from that, I'm going to label the opposite. Adjacent to that, the adjacent. And this guy is always the hypotenuse. Okay. So same thing. We're going to have sine, cosine, tangent. Some old horse came a hopping through our alley. And then we're going to have cosecant, secant, cotangent. Those will be the reciprocals of these. And you are going to have to rationalize on this one if you get the square root in the denominator. Okay.
Okay, so now for sine, it would be 4 square root of 2 over 2. And for cosine, it would be 2 over 6. Good thing for erasable pens. And then that would be 1 over 3. So it would just be 2 to the square root of 2. Okay, so breaking news, we figured out sine was wrong because I put that it was adjacent instead of the hypotenuse, so my bad. You can change that. So then it would be blinking, sorry. So it would be So it'd be 2/3 times the square root of 2.
Hello. Okay, so I'm doing the tangent, which is the opposite over the adjacent. So that equals 4 times the square root of 2 over 2, and the cosecant, which is the opposite of sine, so that's the hypotenuse, over the opposite, which is 6 over 4 square root 2. Where? Yeah. Okay. So, you can't have a square root in the denominator, so that's going to be 6 over 4 square root 2 times 4 square root 2 times 4 square root 2. Okay, well, okay. Can I just finish it? Okay. So 6 times 4 times the square root of 2 is 24 times the square root of 2 over 32 times the square root of 2. And, oh, right, square root of 4. So that equals, what? Yeah. Yep. So that is going to equal, I'll just erase it. Did you say square root of 4? Right. Okay. Yeah. Okay, so I can simplify 24 over 16. Okay, so that would be 8 times the square root of 2 over 4.
What's up, guys? Alright, so before I start, whoever did tangent forgot to simplify, but it's alright. So you just 2 square root of 2 over, or don't even have to put the over 1. So it's just like that, right there. Alright, and then for secant, we have, this one's kind of easy, because it's just 6 over 2, which simplifies to be 3. And then for cotangent, this one's a little harder. We have 2 over 4 times the square root of 2. So you got to move the square root of 2 out of the denominator. So what I did first was I just simplified the 2 and the 4 to make it kind of easier. So it's 1 over 2 times the square root of 2. And then I multiplied by 2 times the square root of 2 times the square root over the square root of 2. And that gives me the square root of 2 in the numerator and 2 times the square root of 4 in the denominator. And then when I simplified that, I got the square root of 2 in the numerator over 2 times 2 in the denominator, which, oh, my bad, I didn't scoot it up. And then that equals square root of 2 over 4. Thank you.
Okay, just to make sure we got the cosecant one, it would be slightly easier if you just took the 2 over square root of 2, or 2 square roots of 2 over 3 and flipped that. So that was sine 2 square roots of 2 over 3. And so you can save yourself a little bit of trouble if it's already reduced. And so cosecant then is just 3 over 2 square roots of 2. And you can just multiply that by square root of 2 over square root of 2. Now, you're not wrong if you do like 2 square roots of 2 over 2 square roots of 2, because that's still 1. But it just makes a little bit less work. So then you'd have 3 square roots of 2. And then at the bottom, you have 2 times the square root of 4, if you multiply what's under the root. So that would be 2 times 2, which is just 4. So if you use it already simplified and then just multiply by that part, it'll just save you a little bit of work on that. Okay, and then the last one of these we're going to do is a little bit different. It tells you the tangent of the angle, and it wants you to find sine and cosine. So at least we don't have to do all 6 trig functions this time. So what I want you to do is draw a triangle. And you can put the angle wherever you want to. Okay, And then tan of theta is 3. Well, we need a ratio, so I'm going to make that 3 over 1. And that's a ratio of opposite over what? Adjacent, yeah. Okay, so what you're going to do is put the opposite of this angle. So that would be a 3, and the adjacent would be right by it. And we have to figure out the missing side, which is the hypotenuse. Okay, so this would be 3 squared plus 1 squared equals c squared. And so you'd have 9 plus 1. So you have c squared is 10, and then c would be the square root of 10. Okay, so we'll put square root of 10 right here. And thankfully, we only need sine and cosine this time. The other ones are easy, except that there's so many to write, sometimes you can get worn out. I will say on your actual IB test, you'll only have sine, cosine, and tangent. You will not have the reciprocal functions. But I quiz you on them a little bit because they are on the ACT, and colleges do expect that you've seen them. So sine, we got some old horse came a hopping. So opposite is 3. Hypotenuse is square root of 10. And we are going to rationalize the denominator. So we'll multiply by the square root of 10 over square root of 10. So you would have 3 square roots of 10. And the bottom, square root of 10 times the square root of 10 is the square root of 100, which is 10. And then cosine would be adjacent over hypotenuse. So sadly, I have to rationalize the denominator again. So times the square root of 10 over square root of 10. So square root of 10 over 10. Okay. Okay, so we're going to just barely start the unit circle. We're just going to do the first quadrant, and then we're going to stop. The unit circle is called the unit circle because the circle has a radius of 1 unit. Okay, so all the way around this distance is 1. Okay, the radius of this circle is 1. 1 what? I don't know, 1 unit, whatever your unit is. Okay, that is 1. And that makes it really convenient as a tool for knowing the trig functions of certain angles. Okay, so what I asked the folks to do in the class was just take their protractor and measure the degrees on the angles that are here. So like right now I'm measuring the pink one. Okay, so if I look at the pink one, it's hitting right on my 30. So what I'm going to do is just write 30 degrees right here. And then I'm going to measure this next one. So this one. And see how wide that is from here to here. Okay, all the pink lines that I've drawn so far they have a length of 1 because it's called a unit circle. So we call that a length of 1. And so if I look at this guy, it looks right between 40 and 50. So this guy is 45-degree angle. And the next little guy, the one that goes right here, okay, it looks like it's hitting right on the 60. And then this guy's one we recognize. What's that? How many degrees? 90 degrees. So I'm going to put 90 right there. Okay, so we're just going to look at that today and how we can come up with these values. We are supposed to know all the multiples of 30 and all the multiples of 45 in a circle. We're supposed to know the sine and the cosine. Those are ones that we're supposed to know exact values for. Anything else besides that, we can use our calculator for. Okay, so I'm going to show you where the unit circle comes from today and only the first quadrant. Okay, so what I want you to do is on your paper, draw a straight line down right here and mark this as 30 degrees. Okay, because we measured that, and that's what it was. Now we're going to make this triangle really messy, and it's going to upset a few people when it looks messy. May or may not be looking at anyone. But it's okay, because once we learn where it comes from and we make it messy, we'll do a nice pretty one that's going to make everybody happy. Okay, that makes it easy to memorize by. So this, we're just doing the down and dirty of it. Okay, so on this, what I need you to know is that the hypotenuse is 1. Okay, that's really important. And because this is 30 degrees, and you can also tell, what is this angle right here? Right angle, 90 degrees. And then what would this be up here? 60 degrees. Okay, so I'm going to draw a little 30, 60, 90 because we just learned the ratios of that. So this would be 30 at the bottom because I'm going to draw it so it kind of matches the way this is. Oh, sorry. So 30 and then 60 and 90. And I'm going to put in the ratios that we talked about. So we said the numbers we want to put are 1, square root of 3, and 2. And that's in order from smallest to largest. So across from the 30 is 1. Across from the 60 is square root of 3. And across from the right angle, or the hypotenuse, is 2. And I'm going to use those ratios to fill in on my circle. Okay, make this a little bit bigger. Okay, so mine is 2, 1, square root of 3. These are similar triangles because they're both 30, 60, 90. Okay, so this is 2. This one, the hypotenuse is only 1. So basically, this triangle is half the size of that triangle. Okay, and it's going to have the same ratios because it's 30, 60, 90. So this hypotenuse is 2, so this hypotenuse is 1. Okay, what's that? Excellent. Okay, now this is 1. So this one's half as big. So how big do you think this side is going to be? A half. And this bottom part is square root of 3. So how big do you think this bottom part is? Yes. Okay, so they're similar triangles, and that's why the ratios are going to be like this. Once you figure out that because this is a unit circle and this is 1, so this side is half as big, all the sides have to be half as big. If it makes you feel better, you could set up a ratio like 2 is to 1 as 1 is to y and solve for y. Okay, like 2 is to 1, that's the hypotenuse over the hypotenuse, equals this side over this side. You're allowed to solve it like that. You don't have to. Okay, once you just see to get from this triangle to this triangle is dividing by 2, you can just divide all the sides by 2. Okay, so what that means is you actually know the coordinates that go here. Okay, you're going over from here to here is square root of 3 over 2, and how high you're going is 1/2. It's the directions on how to get to this point right here. You don't go all the way over to 1. You just go over to here, which is square root of 3 over 2, and then you go up 1/2. So I'm going to fill in those coordinates right here. Now, we're going to be memorizing all the coordinates all the way around here, but there's going to be tons of patterns, and it's going to be really easy. But I want you to see why these two things are useful. Let's say that I wanted to find the cosine of 30 degrees. Yes, I can zoom in. So if I wanted to find the cosine of 30 now, that would be the ratio of which two sides? Some old horse came. Yes, good. So adjacent over hypotenuse. So that would be the square root of 3 over 2. And what's the hypotenuse? 1. So it's just the square root of 3 over 2. Okay, so what happens is, because cosine is always adjacent over hypotenuse, for all three of these, what's my hypotenuse going to be on my triangles? 1. So if your hypotenuse is 1, then adjacent over hypotenuse is always just going to end up being the adjacent, because it's adjacent over 1. So this x value, when we figure it out, is always going to represent the cosine of that angle, just by knowing that. And when we go to do sine of 30, sine is a ratio of what two sides? So opposite of the 30 is 1/2. And the hypotenuse is what? 1. So it's just a half. So because the whole reason they made it a unit circle was so that when you did over hypotenuse, it was just going to be over 1. So that the y value of this is always going to give you the sine of that angle. So it's going to be a fast way that we're going to know once I teach you the triangle, the whole circle, which is going to be easy to learn. There's lots of patterns. You're just going to look, and the cosine of the angle is going to be the x-coordinate, and the y value is going to be the sine. And you can remember that because cosine is adjacent over hypotenuse, so that means it's the x-coordinate over 1. And then sine is the opposite over hypotenuse, so that means it's the y-coordinate over 1. Okay, so the x-coordinate gives you cosine, the y-coordinate gives you sine. What do you think about that? A little weird? Okay, now here's what I'm going to do, and it's a disadvantage you have because I'm using erasable pens. But I'm going to now look at the next one. I'm going to look at the 45, 45, 90. Okay, so I'm going to look at this guy. Okay, so this we already measured was 45 degrees. And what's the hypotenuse on a unit circle? 1. Always 1. Okay, so now what I'm going to do is I'm going to think about a 45, 45, 90. What are the sides on a 45, 45, 90? Remember the ratios? What are the numbers? Okay, but if you look at mine, mine has 1. It does not have square root of 2 for a hypotenuse. So what I'd have to do is divide everything by the square root of 2. Okay, to get from square root of 2, divide by square root of 2, you'd get 1. So to get from this one to mine, I need to divide every single side by the square root of 2. So square root of 2 divided by square root of 2 would give me 1. 1 divided by the square root of 2 looks like that. But we're going to rationalize it. Crazy, huh? So if you rationalize it, you multiply it by the square root of 2 over square root of 2, you get square root of 2 over 2. So this guy right here is square root of 2 over 2 long. Same thing on this side. I'm going to have to take the 1 and divide by square root of 2. So I'm going to get the same answer for this one. Okay, this guy is going to be square root of 2 over 2. So in other words, I'm taking the 1, 1, and the square root of 2 from a 45, 45, 90, dividing everything by the square root of 2 because it's similar. Okay, and so that's what I get. What would the coordinates be right here? Yep. Because to get to that point, I go over square root of 2 over 2 and up square root of 2 over 2. So if I want to figure out the cosine now, it'd be adjacent over hypotenuse. So it's just the x value. If I want to figure out the sine, it would be opposite over hypotenuse. So it would just be square root of 2 over 2 over 1. So just the y value. So all the x values give you the cosines. All the y values are giving you the sines. Okay, so right now I'm telling you where it comes from. Then I'm going to teach you a pattern to make it really, really easy to remember. How are we holding up so far? Okay, for the last triangle that you need to know. Okay, I'm going to erase this guy, and I'm going to erase the sides. It's not fair that I'm erasing, is it? We're going to do just the 60 degrees. Okay, for the 60 degrees, what is the hypotenuse? It's a unit circle, so it's 1. Okay, now I need to compare that to my 30, 60, 90. Okay, so I'm going to draw my 30, 60, 90 over here. But I'm going to draw it so that my 60 is at the bottom. and my 30 is at the top. So it's matching up. Okay, so same triangle as before. Here's 60, here's 30. So this is 2. Across from the 30 is 1. Across from the 60 is square root of 3. Now here's the good news. Compare the hypotenuses. What do you notice? Double. Okay, so this one is double mine. So I'm just going to cut everything in half. Mine is just half of this one. So square root of 3 will be divided by 2, and 1 will be divided by 2. So this guy is a half, and then, because that's how much I went over to get to that point, and then square root of 3 over 2. This is also giving me the sine and cosine. The cosine of 60 would be adjacent over hypotenuse, so a half over 1, so just the x-coordinate. The sine of 60 would be opposite over hypotenuse, so square root of 3 over 2, so that's just the sine. So once we learn all the patterns all the way through, it's just a fast way to know the cosine and the sine for a lot of different values. Okay, so what I'm going to do is I'm going to fill in on a blank one for you. Okay, so now on a nice clean one, now that we kind of know where they come from, we're going to label 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are all coordinates on a circle. The radius of them, of all of these, all the way around is 1. So if I want to figure out the coordinates to get to this point, this is the origin, 0, 0 right here. So I would just go to the right one and up nothing. So these coordinates would be 1, 0. To get to up here, I'd be over nothing but up 1. So this would be 0, 1. When you're doing the y, well, yeah, you want to do x or y first? It doesn't matter. Let's say we do the x's. If you look at the x values, this point right here is the farthest over of all the x values. This one would be a smaller x value. This one is not as far over as this one. It would be smaller, then it goes to 0. So these go from 1 to 0, each one getting a little bit closer. So the values you're going to put are going to be the square root of 3 over 2, and then you're going to get a little bit smaller, square root of 2 over 2, and then square root of 1 over 2. But what's the square root of 1? 1. So you could just say 1/2. But that's going to be the pattern that you're following. Okay, they're starting big and getting smaller because each one of these is closer, smaller x value. Now the y values are getting taller. It's down at the bottom. This one's a little bit higher, a little bit higher, a little bit higher. This is as high as it goes. So if you look at the y values, it's going from 0 to 1. Okay, so I'm going to start out low, and I'm going to do square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. And that's how you're going to memorize just the first quadrant. Now, everything from the first quadrant, I'm going to show you a pattern to get everything else, but pretty much you're going to need to learn how to memorize this first quadrant. And it's pretty easy because the x numbers start big and go down. The y numbers start small and get bigger. What's the one? There's something I hadn't filled in on here, isn't there? You see anything? Radians, yep. You can't know that's what I wanted unless you've already seen the unit circle before. But the last thing we need to fill in for the unit circle is the radians. And we just need to convert it. You need to memorize the radians for the first quadrant, and after that I'll show you patterns that'll help you figure out the whole rest of the unit circle, but not today. Today's just first quadrant. Okay, so 0 degrees, how many radians do you think that is? 0. Okay, now 30 degrees, I'm going to take a minute and I'm going to change it. Yeah. You don't have to. I just did it so it would look like the pattern, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2. But square root of 1 is just 1, so you can just put 1/2. I was just doing it so it would look like a 3-2-1 pattern and then a 1-2-3 pattern. Okay. Okay. So that's the only reason I put it on there, but you totally don't need the square root over the 1 because square root of 1 is 1. So that's a good question. But 30 degrees, I'm going to change that. So if you'll remember how to change between degrees and radians, there's 180 degrees is pi radians. So if you multiply that, you have 30 pi over 180. And if you reduce that, 30 goes into 30 once, 30 goes into 180 6 times, it would be pi over 6. Okay, you are going to want to memorize the values in the first quadrant. You're going to want to know in your head 30 degrees is pi over 6. Okay, if you just memorize the first quadrant, everything else I can give to you with patterns. 45 degrees, we're going to do the same thing. Okay, so I'm just going to scoot it up a little bit. 45, and you're going to do the same thing. Pi 180. Sorry. So you would have 45 pi over 180, and you're just reducing that. And you can do that on your calculator. You can do 45 divided by 180. It reduces the fraction for you. But if you think about it, 45 times 2 is 90, and then you've got 2 90s. So this is actually 1/4. So this is just pi over 4. You are going to want to memorize that that's pi over 4. Now it's not that hard. Because, particularly for those, because if you remember, how many radians in the entire circle? Yeah, 2 pi. So if I go all the way around, that's what this is for, by the way. It's 360 or 2 pi if you go all the way around. But if you go halfway around, how many radians would that be? Pi. So if you're just half of pi around, that's pi over 2. And half of pi over 2 is pi over 4. Okay, but you're going to want to know 45 is pi over 4. And then the very last one is 60 degrees. If you think about it, 60 degrees is twice as big as 30 degrees. So you could do it that way. I'll just do it the typical way. Okay, the traditional. So 60 degrees. So this would be 60 pi over 180. And 60 goes into 60 once, it goes into 180 3 times, so this is pi over 3. Okay, so that is the first quadrant of your unit circle. You're going to have a unit circle test next week, but I'm only showing you the first quadrant because, not on Monday. I want you to do your quiz on Monday. If the YIG people want to, they can get it done on Monday, and if they would rather make it up in a directed studies, they can, because everybody knows what the 3 questions on the quiz are. 6 trig functions, 6 trig functions for 45, 6 trig functions for, and I'll either say 60 or 30. Okay, but this is just to get you started. You'll want to memorize the first quadrant, memorize the patterns. I will teach you patterns to know the rest of it. And by the end of next week, at least, we'll do a test grade, and be just memorizing this. Okay, all right, we're going to stop there for today.